Right, so thank you for coming. And before we start, please raise your hand if you have ever written at least a single line of Python code. Good. Now, please raise your hand if you're using Python at your job. Oh, that's great. All right, so we'll be talking about programming Unix utilities in Python. And let me start by explaining what this title actually means. And that is what I understand, what I mean by utility, what are Unix-like systems, and why Python. So I think we kind of have an intuition of what a utility is, but just to be clear, let me explain this. What is a utility and how it differs from a non-utility. So utilities are things like programs like find or curl, right? Those are tools that help you do your job, and particularly in Unix, those are tools that you connect. Like each tool does one job, and you connect them to perform more complex tasks. So to do this in Unix-like systems, it means that you're working with terminal, with command line interface. And so by utilities, I mean programs with command line interface, as opposed to, for instance, web applications, desktop applications, mobile applications. Unix-like systems, again, I think we all kind of know what is a Unix-like system, right? I mean, all Linux distributions, OS X, BSD, but in fact, we'll be talking about Python. So essentially, wherever Python works and wherever you making command line utilities makes sense, you can apply this presentation, right? So even Windows applies because Python runs there, and you may use command line utilities. So if that makes sense for you, then basically anywhere. But I will be focusing on Unix-like systems. I'm working with them, and actually I don't have much experience with Windows, so that's why Unix-like systems. And why Python? Well, first because Python is an interpreted language, which means you don't have to deal with the burden of compiling stuff, building stuff. You simply write your code, execute it, and that's it. So you don't have to even have any tools to program, right? You just need a text editor. So you can, for instance, log in over SSH to some server, modify some file, some script, and that's it. You can run it. So it's pretty convenient. However, Python wasn't designed to be a scripting language. It's a general purpose language. And as such, it provides basically all the tools that general purpose languages provide. It's good for object-oriented programming, functional programming. It has vast standard library. It has packages. So everything is there. So you can benefit from that. And for lack of better words, it's mature language, which means it has been designed a while ago. It's already pretty stable and well-designed language. So it has great documentation. It's actively maintained. It has great standard library. So basically, it's a pleasure to work with it, right? Now, just to remind you, I will be talking about Python 3. So I encourage you to use Python 3 instead of 2. Although I realize that if you're making utilities for servers, it may happen that Python 3 is not available where you want to deploy your code. So you may end up with Python 2. But I think everything I will say applies to Python 2 as well. So So I just want to encourage you to use 3 if you can. Now, why command line interface at all, right? Well, it turns out that it's still pretty common to use it, right? Not only power users like Hackerman use command line interface. Basically, sysop, DevOps, whatever ops people use it to automate their job dealing with the infrastructure, even the day-to-day tasks. Also testers, for instance, tend to use scripts to automate their job. So, well, it's pretty common. So I think this presentation will be relevant. So, first I will talk a little bit about some basics, and then we'll dive into dealing with command line interface, and at the end I will talk about delivering your code to your users. So first, some basics, how to write scripts in Python at all. So first, how to get Python. Well, on the server, it means that if you're writing an application for a server, then it means that Python is probably already there. If it's a Linux distribution, that it's either already there or you can install it from an official repository. So that's pretty easy. Although if you have to install it, then you will need root privileges. But I guess that will be a problem if you are owner of the infrastructure. On the desktop, it may be there. If it's not, you can easily install it. Most desktop distributions, Linux distributions, have Python in official repositories. On Mac, you can brew install Python 3, and that's it. So it's pretty available there. So to run Python, well, it's simple. You write Python, name of the file with the code, and that's it. To be sure that you're running Python 3, type Python 3, because it may happen that you have multiple versions on a host. So to be sure that you're running Python 3, simply type Python 3. Shebang line is pretty useful. Write it as a first line of your source file and make it executable, and you can run without typing Python. So this form of shebang here is, I think, the most it will work practically everywhere. So also, you may hear people using terms like script, program, module interchangeably, and that's because it all refers to files with py extension, which means that you can, when you have a .py file, you can either run it from a command line or you can import it. And it's important to realize that, because importing means executing. If you are importing a file, you execute everything that's there. So if you have a file like this, and there is a call to the function main, if you run it from a terminal, this function will be executed, and also if you import it, it will be called as well. So keep in mind that, and if you want to have a file that you can either run or import, then you can use this if name equals main idiom. Underscore name is a variable that stores a name of a module, and if you are running this module from a command line, that name would be underscore main. So you can use this to separate code that will be executed when you run your code from console. Also, it's, I think, essential to learn standard library because it provides you so many tools that will make your job much easier. For instance, and I don't want to go over the entire standard library because we would have to stay here for another week, but I want to just tell you about the most common modules that are, I think, very useful when you're writing command line utilities. So module like OS, which stands for operating system, it helps you deal with operating system. You can find like environment variables there, or OS path module, which provides you tools to deal with file paths. Like you can check if a file under a given path exists. So there's like you will definitely need this if you are dealing with files. Shutil, which is shell utilities, it gives you some higher level functions to deal with files and directories. You can use it to move files, remove files to list directory. There's a temp file library that helps you deal with temporary files and directories. Platform, which gives you insight into the platform that you're running on, so you can check the architecture or get more details about Python that you're running. And subprocess module, which allows you to run subprocesses. So if you want to call another program, then subprocess is the way to go. Now let's talk about dealing with command line interface, and let's start with output. So obviously there's a print function, but the print function used like that, well, it's okay, but if you want your code to be really to work according to follow all the rules, then you should separate the messages that user should see from the error messages. So you should use standard output and standard error streams, and you can do this by importing sys module, which gives you tools to deal with the system, and it has two objects, std out and std err. The first one represents standard output object, standard output stream, and the other one standard error stream. And print function has a file argument. You can pass this object to print function, and it will print there. And it will allow you to do things like redirecting standard error to a file, which is pretty convenient. And if you're writing especially some utilities for dealing for I don't know, maybe managing your infrastructure, then DevOps people will be happy to see things like this. Now input, it's obviously input function, which stops the program, waits for user to enter some text, and then it returns that text. And you can also pass an argument, which will be the prompt message that user will see before entering the message. You can go deeper and again use the sys module, where you can find stdin object, which is a standard input, and you can read certain number of bytes from it. And because it's basically a file, it behaves like a file. You can iterate over it. So, for instance, if you're piping a file into your script, you can iterate line by line. And it also gives you a function like is a TTY, which tells you whether the input is interactive or non-interactive. And interactive means that you can assume that there is a user in front of the terminal, so you can safely ask him for some input if you need something. If it's non-interactive, it means that your script was invoked in some other way, so you cannot assume that user is there. And if you're expecting some input, you don't have it, then, well, probably you need, in this case, to throw an error. Also, another phase of input is command line arguments. And again, you can use sys module. It has argv object, which is a list of command line arguments. The first item on this list is the program name, and the rest is basically all the arguments that user passed, and they are strings. And, well, because there's basically no logic behind this. This is just a list of strings, and you have to always check what user has entered. You have to validate that input, and argparse module from the standard library will be will be helpful. I don't want to go over all the details of this module. It's useful, but there are better ways to do this. I will talk about them in a minute. So I just will show you how this works in general, so that you know that this is there. All right, so it works like this. You define a parser, then you add arguments, basically defining them, what are your requirements for them. You can define some help messages as well. Then you call parseArgs method, which returns your arguments, and basically that's it. The interface is simple, although there are many options. So it's a powerful tool, however, very verbose. So you have to write a lot of code to deal with this. That's why I think there are better methods to do the same thing. So another kind of input is password. So basically, when you ask user to give you a password, you don't want to display it on the screen. It's not safe. So you want a tool that will ask user to enter password but not show it on the screen. And here's where getPass module is helpful. It gives you getPass function, which will stop the program, print the message, ask user to enter password, get the password without displaying it, and return it. And a little bit about files. Files are not very specific to command line utilities. However, as you already saw, input-output streams behave like files. Also, it's very common that people using command line utilities expect them to work with files. So just a quick overview how to deal with files. You open files with open function, which accepts the path of the file, opens it, and returns a file object from which you can read. If you call it like that, you will read the entire file. You can read a certain number of bytes. You can iterate over it line by line. You can use it as a context manager, which means after that you define the with block, and when Python exits this block, it will close the file gracefully. So it's pretty convenient. You can also write to a file. You have to pass the second, in this case, you have to pass the second attribute, which is a mode in which you open file. If you write W, it stands for write, so you can open the file for writing and then write some data. This mode attribute basically has accepts many values, so you can add letter B to tell that you want to work on bytes, which is pretty convenient when you want to work with binary files. Now, I wasn't talking about validation much, and I didn't want to go more into details of what you saw before, because doing those things manually, validation, for instance, well, it's okay, but it takes a lot of time. And there are better ways to do this. Basically, when you write a command line utility, you don't want to spend a lot of time on the interface itself, right? It's that simple. You always want to do the same things. You want to validate the input and give some output, right? So you want to spend your time on your business logic, not on the interface itself, although you want this interface to be predictable. So this is where Click library comes in. It stands for Command Line Interface Creation Kit. It's a third-party library that you can fetch from Python package index, and it basically handles everything related with command line interface. So you import it, you download it, install it, and you can import it and use it. And just let me give you a quick overview of how this works. So imagine you want to write a simple utility that will run some tests. We have this imaginary function called run tests, and it accepts one argument, which is a name of the component that you want to test. So you want to have a utility which you will run from command line and pass it only a single required argument, which is a name of the component. And if in Click you would do this like this, you use the decorator command. So basically you start by writing your function and you assume that you will get all those arguments that you require, like component name in this instance. And then you decorate the function with the decorators that Click provides. So you use the command decorator to indicate that you are going to define a command, and then you use the, for instance, argument decorator to define your arguments. You can define them as many as you want, and like to give you the feeling of how this works, just give me let me show you a few examples. So let's redefine the ls command from Linux, like the very basic form of it. So it will accept a path which we want to list, and it will accept an option that will tell that we want to show we want to see the output in a long listing format. So in Click, you would do this like this. You would define an argument, which is required. However, it has a default value that equals to the current directory. And then you have this option decorator, which tells that there will be, you want to accept -l flag. It will be the variable in the argument in your function that you defined below will be called long listing, and you want to indicate that it will be a flag, which means you either expect it to be there or not. So you want to have a boolean basically. And in RM you want to have, for instance, just a list of paths. So you can explicitly say how many times you want user to give this argument. So for this you're using nargs parameter, and if you set it to -1, it means that you expect you allow user to pass as many arguments as you want. And you can also set a type for this argument, and you can say that it will be a path, and you can even tell Click to check if it exists. You can tell Click to check if it's writable, readable, and so on. So it's like you just saved yourself a few lines of code there. If you want to define a MySQL client, you can define ORIOL options, like with option decorator. You can define for each option two forms, the short and long one. So for instance, with user you would have --user or -u. Like there in the second option, host, you can say that you want Click to call a callback to validate this option. So you define somewhere your validate host function. Click will call it, and you can check if the host is valid. For instance, if it is an IP address, you can also check some basic types like integer, and you can ask user for password. So you can define an option, and if user doesn't provide this option through the command line, and we set this prompt equals true, then Click will prompt user to enter this value of this argument. And if we set height input to true, then this input will not be shown on the screen. So it's very convenient when you are asking for passwords. Click also deals with output, so we can use echo function which basically works like print. You can pass argument set to true to make sure the output will go to standard error. And again, this saved you like at least one line of code. You can format the output with secho function. So you can set the text color to red, for instance, and make it bold, which makes printing a nice readable output that simple. So yeah, there's a lot of more in Click. So you basically want to go to documentation. It's really comprehensive and easy to read. There are a lot more stuff there that will save your time. So basically, if you can use a third-party library in your project, then do this. Use Click. it will definitely make your life easier. If you can, then well, at least use argparse because you have to validate user input. Yeah, and now let's talk about distributing your software. So the fact that you are writing a command line program doesn't mean that your users are hackers, and even if they are, they don't like to, figure your program, spend time on figuring your program, how it works. They are users. They just want to install your program and use it. So don't forget about that. And what it means is that you have to deliver your program in a way that it makes it easy to install and run. And in Python, it's pretty simple, usually. So, well, the client has to have the user has to have a Python installed. So we already covered that. It's probably already there, or user can install it very easily. But then you just have to deliver the source code in some way. There are many ways, but somehow you have to get the source code there. You don't have to compile anything. You just get the files and that's it. And you have to install dependencies. So if there are any, and that's it. You get the source code, you install dependencies, you can run your program. So theoretically, delivering code in Python is really simple. But there are many ways to do this, and the way we are looking for should be one that is familiar, that users are familiar with, that will preferably do all those things automatically, so user won't have to do a lot of work to get this done. And in Python, I think the best way to do this would be to define a package, Python package, because if you make your code into a Python package, then it will be easy to install with pip install, and pip install basically will take care of everything. It will get the code from wherever you placed it. It will install dependencies. It will distribute all the files in proper places. So it will do basically the entire job for you. And people know pip install, right? So they are not afraid of it. So you can just tell user, use pip install to install my package, and they will be okay with this. So I suggest you should use packages, and let's go through defining packages, because many people don't know how to do this, and it's pretty simple. So we have our project, whatever it does. We have it in an example project directory, and what we have to do is just first define the directory where we will put our source code. This will be the package directory. Here it's called example. Then there we put underscore init file to indicate that it is a package. Then and that's basically it. If you want to define the package, but we wanted to have a separate module for for everything related with command line interface, and we want to have business logic separately. So we have this CLI.py file and the library module. And right next to the example directory, we have setup.py file, where we will define our package, how it works. So in the CLI.py, you basically place here the code that you usually would write, like your script, basically. So you have your main function, which runs some function from your library, and obviously you probably have some command line arguments. So you want to use click here, etc. So you basically define your script here. What is important is that you don't have to use this if name equals main, because at the end user won't be running this script directly. So you don't have to care about this. Now, in the setup.py file, you basically have you have to use this setup tools module, which provides setup function, and all you have to do here is call this function and pass it arguments that define your package. So you can set the name of the package, the version, because your package can provide multiple packages. Like previously on the previous slide, you saw that there's this example directory. In your package, you can define multiple such directories. So you basically can have many packages inside one Python package. You can list them manually, but you don't want to. You can use this find packages function, which will do this job for you. You can define all the requirements with install requires attribute. So for instance, here we are defining that we require click in version 6.7. And lastly, there's this entry points parameter, which looks kind of scary, but it's basically a string with this configuration file style content. You have this header, this section console scripts, where you can define the scripts that Python upon installation will extract from your code and make available to the user. So, for instance, if you want your application to be available as a other name example, so user will just type example, hit enter to get your application, you have to define this key. Example, type equals, and write value for this key. And the value is basically path inside your package to this function you want to call. So in our case, we type example, the name of our package, .cli, the module where we have the function that we want to call, colon, and then the name of this of the function that we want to call. So this is why you don't have to, in your script, write this if name equals name, blah blah blah, or even call your function, because people will take care of this upon installation. And basically that's it. You defined a package, and right now user can already install it with pip install. That's basically it. So what can you do next? Well, preferably, you want to distribute your package, right? So you have to make it available to the users. And I think, the way you do this depends on your preferences, but I think the easiest way would be to push this to some repository that is available to all your users. So if you're writing a tool, an open source tool, then you can push it to, I don't know, GitHub, Bitbucket, wherever you can, to any public repository. But I bet you want to make it available only to your organization, so you can push it to some private repository, wherever it is, to your GitLab, right? And once you do this, and assuming that users have access to this repository, they can simply install it with pip install. So for instance, if we pushed our code to GitHub, to some private repository, it could look like this, pip install. Then the notation looks scary at first glance, but it's simple. You say that you want to download it from Git, then you type the path to the repository, and people know that it has to clone your repository. It will find setup.py file there, which will tell what are the dependencies, what are the packages to install, what are the scripts to distribute. So it will do all the job for you. And basically that's it. So users will be happy because they will have only this one simple command to run to install your software. So I can imagine like doing it even simpler. Yeah. So let me sum things up. Use Python because it's perfect language for dealing with, for writing command line utilities. Not because it was designed to be so, but because it is a general purpose language, very well designed general language, general purpose language, which means it fits for many purposes, and command line utilities is just another way to use this, and Python fits it very well. It gives you all its powerful tools, and it's interpreted, so you can combine those two things and easily write applications, command line applications. And when you do this, remember to use Click. Well, if you can use third-party packages, it will save you a lot of time. It might make your life easier. And use packages because it's basically the cleanest, simplest, and the most known way to deliver software in Python. So people won't be afraid of this. They will just run pip install and that's it. So if you're interested in things more like that, if you like this presentation, then visit my website. I will put the slides later there, although I think it will be somewhere on the conference pages as well. Yeah, you can contact me on Twitter, and don't remember to see the other presentations about Python at conference. There will be 2 more presentations by Łukasz Langa, so I encourage you to see them. I bet they will be awesome. So thank you.